Okay, so I broke this up into part two, just because this was a long section. So before we were using transformations for given graphs. Now we are going to have to recognize some basic functions. And so the first basic function we need to recognize is the quadratic function. And so I've talked about this a couple times in previous videos. And so right here, the way you recognize it, that you're dealing with the quadratic is if you have a x squared somewhere involved or a square involved. And so this is the picture. This is known as a parent function. It's just the most basic one. And so you can see right here, if you were to square -2, you would get a 4. If you were to square -1, you would get +1. 0 squared 0, and then +1 squared is 1. 2 squared is 4. So what we're going to do is you have to recognize what function you're dealing with, and then you're going to use your transformations uh, to go ahead and move it. So what I like to do is pick three key points, and you can really pick whichever ones you want, but I just picked these three right here. They're the easiest ones to memorize and to work with. So what you want to do is you start with those points, put them on the graph, figure out the transformation, and then apply it and graph your new function. Okay, so each one of these, we're going to start out pretty easy, but by the time we get to the end of each individual basic function we look at, we'll start dealing with multiple transformations, and it could be a little challenging, but we'll start out fairly simple. So looking at this first one right here, so what I like to do, I plot those 3 points right there. You don't actually need to draw the parabola, but that's the parent function. Now what's happening to the parent function? Well, this is the parent function, and you're subtracting 2 from it. Now remember, g of x is the y value of your new function. So the y value of the parent function, all the y values are decreasing by 2. So that's going to be a vertical transformation of going down 2. Okay, so on the previous part over here, we were kind of looking what was happening to f of x, right? That was the given function, what happens to f of x. Now we're looking at what happens to the parent function of quadratics, and in this case, it goes down 2. So that's what we'll do. We'll move all these points down, oops, too far on that one, down 2. So we move them all down 2, and then you just draw that basic shape of your parabola. Now, since we're kind of confined to using the computers right now, it should be multiple choice for most of them. Some of them will have you plot the parent function and use some transformations to move the graph. And so you'll just have to see some of them multiple choice. Some of them you'll basically tell it that there's a vertical transformation of down 2, and it will shift the graph for you. Okay, looking at our next one, so the transformations just like from the previous section. So you see right here what we're doing to x, we're subtracting it by 1, so that's going to cause a horizontal shift. Now remember, it's the opposite of what you would intuitively think. So subtracting x by 1 is actually going to cause us to go right. We're going to go right 1. So we'll have our three key points. That's the original. That's what x squared is. That's what just x squared is. But once you introduce that -1, it's going to cause all those points to shift over to the right 1. And then we'll go ahead and draw our graph. And there we are. Okay, our next one, we have two transformations. You always want to do horizontal first, and then it looks like we're going to have a reflection right there on the second one. Color code that a little bit. So the first transformation is going to be to the right. We're going to go right 2, and then this is going to reflect across the x-axis. All right, so let's see, the original points are right here, and we're going to go right 2, go to the right 2, and then reflect across the x-axis. So that first point right here ends up over here. Then right 2, and then my reflection, I'm on the line of reflection, so I stay right there. See, right 2, reflect across, I end up right there. And then we'll we'll just draw our parabola shape right there. Okay, and if you want to, you can plug in some of these points in for x, and you'll get the, so like if you were to plug in 3, you'll get -1 for your h of x or your y value. So if you want to, you could plug in 3, and you'll see that that happens if you just want to dive a little deeper into this. But transformations are there to make life a little bit easier. All right. Looking at 60, let's see, so we're going to go right. Go right 1, and we're going to go up 2. That's a pretty easy one. So we'll go right 1, up 2, right 1, up 2, right 1, up 2. And there we are. Okay, our next one, let's see. We are going to go right 1 again. And then we're multiplying by 1/2 right here. And so, see, you plug in x, you move to the right 1, and then you're multiplying by half. So really what's going to happen is the y values are going to get cut in half. So basically, my transformation, I'm going to describe it as multiply y by 1/2. All right. And so you could also look at that as a shrinking vertically. Okay. So let's go ahead. Let me go ahead and plot the original 3 points. And we're going to go right 1. And then my y value gets multiplied by half, so it goes down here. And then go right 1. My y value is already 0, so I just stay right there. Right 1, my y value shrinks in half. Okay, so what's going to happen is it's going to cause the parabola to open up wider. It's going to cause it to open up wider. Just to make this a little bit more clear, I'm going to add a couple more points. So, you know, for the parent function y equals x squared, if I were to plug in 2, I'd get a 4, right? And if I plug in -2, I'd get 4 also. I'm going to go ahead and move those points real quick just so it makes my graph a little bit more accurate. So go to the right 1, and then my y value gets cut in half. Go to the right 1, my y value gets cut in half. So I just added a couple extra points just so we could really see how that's causing it to widen out a little bit more compared to the other graphs that were a little bit narrower. Now what you're going to see on this next one is the opposite, because you're going to multiply by -2, and that's actually going to be 2 transformations right there. That's 2. But let's go ahead and do our horizontal first. So this time we're going to the left. We're going to go to the left 1, and then multiplying by -2, it's going to cause it to stretch by a factor of 2, but it's also going to cause a reflection across the x-axis. And so I'm going to go ahead and I'm just going to say multiply y by -2. That will actually take care of both transformations. It'll cause me to stretch it, and then it will cause me to reflect it also. And then the last one, we have the +1 right there, so that's going to be up 1. So let's put the original points here, these 3, and then you just have to follow those directions. So let's see, we're going to go left 1, multiply y by -2. So when I multiply y by -2, it's going to 1 times, my y value currently is 1, so now it's -2. So see, it reflected and it stretched. It reflected and stretched, and then I have to go up 1. So I actually end up right here. That's where that first point right here ends up. Okay, left 1, multiply y by -2, so my y is -2 now, and then go up 1. Now my next point right here will go left 1, multiply y by -2. Well, y is 0, so I stay right where I'm at. And then I go up 1, so I actually land on that first point I had moved. And then the last point right here will go left 1, multiply my y by -2, so I flip and stretch down here, and then go up 1, so I end up right there. So this graph is actually going to be little bit narrower because you multiplied by -2, or more importantly, the 2 caused this to narrow up. The negative caused it to reflect and open down. Okay, our next basic function we're going to look at is the square root function. So the 3 key points we're going to use here is 0, 0, 1, 1, and then we want to jump to 4, 2. And the reason why is the square root of 2 and 3, those are decimal answers, so I'd prefer to avoid those if I can. So just a little note, square roots can only be evaluated at non-negative numbers in order to return a real number. So we want to just focus on non-negative, which basically means positives, and then also we can include 0. You can square root 0 without a problem. Also, you typically want to evaluate square roots at perfect squares, and so that's why we skipped the 2 and the 3. So if you're going to keep going, the next one you would want to do is 9. And over here at 9, square root of 9 would be 3. But we'll go ahead, we're going to focus on these 3 points and using our transformations. So the way you recognize this, the parent function, pretty basic, it's just square root of x. So our first one right here, we're going to add 2 to my result, so that's going to cause us to go up 2. So from the parent function, you're adding 2 to all your results, which is basically your y, so we're all going up 2. So the original function is right there, that's the original. Move them all up 2. And there we are. It basically is like half of a parabola, but on its side. That's kind of the shape it takes. Okay, our next one, this time we're adding to directly 2x. So it happens before you apply the square root. So you got to do your horizontal transformation, which is going to be left 2. We're going to go left 2. So we'll go ahead and plot that, move them all to the left 2. And there you are. Okay, our next one, we've got 2 transformations. You always got to do your horizontal transformations first. So that's going to be left 1. And then we're going to reflect across the x-axis, or if you just want to say multiply y by -1. Now, if they ask for a description, it's a reflection across the x-axis. But sometimes I just kind of like to write out what I'm doing. All right, so let's see. We're going to do here, here, and here. So see, we'll go left 1 and then reflect or multiply y by -1. I stay right there. Left 1, and then when I multiply by -1, I reflect across. And then left 1, multiply y by -1, so I end up at -2 down here. So it's going to cause the parabola to open down into, or I'm sorry, the square root function to open down into the right. So let's see. There we go. Okay, the next one, let's see, we have to start with the +2, which is going to cause us to go left 2. And then we have a reflection across the y-axis, which we don't, oops, let's do a different color on that, which we don't really see that often. I mean, it can come up, but reflection across the x-axis is more often. But anyways, so I'm actually going to write that one out. So reflection across the y-axis. I just want to write it out just because it's a rare transformation. We'll probably only see it maybe one more time in the notes. So let's see. We start out with our original function here. By the way, here's our y-axis. And so we're going to go left 2. So left 2, and then I go across the y-axis, so I end up over here at +2. What's interesting about this next one is I go left 2 and reflect, and I actually land right back where I was. So the 2 transformations actually lead me right back to where I started on that second point. And then the last one, I go left 2, and then I have to reflect across over here. And so this time, the square root function is actually going to go out to the left. There we go. All right, and you can plug in some values if you want to play around with it and see how that transformation works. All right. Let's see our next one. Let's see, we're going to go left 1. And then we're stretching by a factor of 2, but I'm going to go ahead and just say multiply y by 2. Okay, so you plug in x, that plus 1's causing us to shift left 1, and then you're multiplying the result by 2, which your result in the end is the y value of your function. All right, so let's plot our points. And let's see, so we're going to go left 1, multiply y by 2. Well, y is 0, so I'll stay right there. Left 1, multiply y by 2, so I'll go up here. Left 1, multiply y by 2, so I shoot up to 4. So this is causing this to increase at a faster pace as I go to the right. All right, so the last one here for square root functions, we're going to start by going left 2, and then we're going to go down 2. So we'll put the original points for the parent function, and then we just have to make this transformation. So left 2, down 2. Left 2, down 2. Left 2, down 2. Oops. All right. Just try to draw it with a smooth curve, and there we are. All right. The next type we're going to look at is the absolute value function. It operates a lot like the parabola, except that it's a V-shape. It's going to be V-shaped. But we're actually going to use the same 3 key points we did with the parabola. You just need to recognize the absolute value function, which is pretty simple. It's just got those hash marks to indicate that. So on our first transformation right here, we have a plus 4, so that's going to cause us to go up 4. So I'm just going to take those 3 key points, these 3 points, we're going to move them all up 4. So up 4, 4, and up 4. And here we go. There's our first one. Now the only difference on the next one is I have the plus 4 in the absolute value, so it's occurring prior to evaluating the absolute value. So that's a horizontal shift, and so that's going to be left 4. We're going to move them all to the left 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then we'll go ahead and draw that, put some arrows on the end, and there you go. Okay, our next one, so we're going to have a plus 3, so that's going to cause us to go left 3. We have a minus 2, so we're going to go down 2. So once again, I'll put those 3 starting points, and we'll go ahead and move them. So left 3, 1, 2, 3, down 2. Left 1, 2, 3, down 2. Left 1, 2, 3, down 2. And then let's start using this to make it a little bit neater for me. There and there. There we go. All right, so I got a couple more down here for us. So looking at this first one, we have a plus 3, so that's going to be left 3. And then we have the negative in front, which is a reflection across the x-axis, or multiply y by -1. It will accomplish the same goal. It's the same thing. So we'll go ahead and plot those original points right there. So I got to go left 1, 2, 3, and then multiply y by -1, which reflects me across. Left 1, 2, 3. I'm on the line of reflection, so I actually stay right there. Then 1, 2, 3, reflect across right there. And we'll go ahead and draw my absolute value function. Okay, our next one, we have the +4, so that's going to be left 4. And then we have the ×2, which is going to cause us to stretch vertically by a factor of 2. So I'm just going to go ahead and say multiply y by 2. So we'll go ahead and put this here. So we'll move to the left 4. 1, 2, 3, 4, and then multiply y by 2. So I go up to here. Left 4, and then my y value is 0, so multiplying by 2 doesn't change that point. And then left 4, multiply y by 2, I pop up right there. So you can see it makes the graph a little bit narrower. All right. All right, our last one of this type here, we got 3, well, actually really 4 transformations going on here. So we'll start by going left 3, and then multiplying by -2 causes a stretch and a reflection. So see, that's why I kind of like using the description with y. It is a stretch and it is a reflection, but I'm going to go ahead and say multiply y by -2, and that will actually take care of both of those transformations when I have to perform them. And then the last thing is the +2, which will cause us to go up 2. So we start with our original points right here, and we'll go ahead and move them. So left 3, 1, 2, 3. Multiply y by -2. So it's going to cause me to reflect and stretch down to -2. And then I have to go up 2. So I actually end up right there. Right there. So left 1, 2, 3. Multiply y by -2. And then my graph shifted up 2. Okay, my 0, 0 point, so let's see, left 3. When I multiply by -2, the y value is already 0, so nothing happens, and then I'm going to go up 2, so I end up right there. Then my third point, go left 1, 2, 3, multiply by -2, so I reflect and stretch, and then go up 2, so I'm going to end up right there. And so we'll go ahead and draw our absolute value function. Let me see. Yeah, there we go. Okay, so we've covered the quadratic, the square root, and now the absolute value function. I have 2 more that we're going to look at, but I'll go ahead and do that on a second video.